KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.com.
In continuation to the last class, in this class we start with 9.3 stress and strain. In our previous class, we started this chapter as a new chapter, mechanical properties of solids. There we had a discussion about what is a solid material and how it is different when compared to liquids and gases, and there itself what is elasticity and what is elastic deformation, and then what is plasticity. After completion of that, we discussed there itself what is elastic behavior of solids. So by taking a minimum of 2 balls and 1 spring, otherwise by taking a whole spring ball model, we discussed how the balls are going to change their equilibrium positions. Their equilibrium positions when you apply certain amount of force, that is what we can call it as deforming force, right? So when you are going to withdraw the deforming force, it will regain its original shape and size. There itself we also discussed what is Hooke's law, so which is very important, and that is the working principle of spring balance, what we are using in our daily life or in our physics lab to measure the weight of different objects. Okay, right. So in this class we start with 9.3, that is stress and strain. So which is most important for NEET point of view also, because here we are going to get some definitions, some formulas and including the concept. So first we have to understand the concept, and then if you get any new physical quantity, what is the units of the new physical quantity, and what is the dimensional formula of new physical quantity, and what is the formula to calculate the new physical quantity, along with the 3 different, that is what here we are going to get about 3 different types of stress, similarly 3 different types of strain. And for all the 3 different types of stress and strain, what are the formulas? That is we need to remember, we need to memorize. Okay, right. So first stress and strain. Stress and strain. So this word stress, even in our daily life also we are using. So being an employee, so either software employee or any other employee, or because of some business purpose, generally sometimes we hear the word stress. So nowadays I got lot of stress and I am going to expose more stress, like that, right? So basically see, when forces are applied on your body in such a manner that the body is in static equilibrium. Static equilibrium. Even though it is deformed to a small or large extent depending upon the nature of the material of the body and the magnitude of the deforming force. So what I am saying is, when a body is exposed, when a body is going to experience certain amount of external force, that is what we can say that when forces are applied on a body in such a manner that the body is in still static equilibrium, it is deformed to a small or large extent depending upon the nature of the material, of the body and the magnitude of the deforming force. For example, If we take two different materials, for example, iron and a rubber, even though you applied the same amount of force, the amount of deformation taken place in case of iron and rubber will be different, because the nature of iron is different from nature of rubber. So that's why the amount of deformation, the quantity of deformation depends upon the nature of material also, not only on the magnitude of applied force, which you can also call it as deforming force. It also depends upon the nature of material also. It also depends upon the nature of material. Okay, ma? Right. Sometimes this deformation may not be noticeable visually in many materials, but it is there. But it is there. Okay. So when a body is subject to a deforming force, a restoring force is developed in the body. Okay, right. So from starting of this class, I am trying to explain what is stress. So what is stress means, when a body is exposed to certain amount of force, so that force, that applied force, the deforming force cause a change in the shape or size, which is called as deformation. So even though the force is same, is equal in magnitude for different types of materials, the deformation is not same. It depends upon basically the magnitude of applied force, secondly the nature of the material. That's what I want to say clearly. After completion of that, what I am saying is, when a body is subjected to a deforming force, a restoring force is developed in the body. Try to understand the word restoring force. Try to understand the word restoring force. For example, you take a piece of rubber material and you just apply certain amount of force in your own manner. Then what will happen? The rubber material is going to deform, right? So now if you are going to withdraw that applied force, what will happen? That rubber material will regain its original shape and size, right? See, in this example, the force what you are applying on the rubber material is deforming force, but the force due to which the rubber material regaining its original shape and size is called as restoring force. So please try to understand, the force applied by you on rubber material is deforming force. The force applied by the rubber material itself, to regain its original shape and size, is because of restoring force. So restoring force is the force applied by the rubber material in this example. Deforming force is the force applied by you on the rubber material, right? Okay. When a body is subjected to a deforming force, a restoring force is developed in the body. This restoring force is equal in magnitude but opposite in direction to the applied force. So it's an important sentence, no? He is talking about the magnitude of restoring force and deforming force. So as simple as such, he is saying that the restoring force, this restoring force is equal in magnitude but opposite in direction to the applied force. Okay, full stop. The restoring force per unit area is known as stress. So you please try to memorize this definition. Stress is defined as the restoring force per unit area. The restoring force per unit area is known as stress. Okay. So regarding the formula, magnitude of the stress is equal to force by area. Right? Okay. So what is the force? What is the F? F is the force applied. What is the A? Area of cross section of the body. Right? I want to give some clarity here, ma. See, area of cross section of the body means, in our daily life, even in our kitchen, we can see materials of different shapes and different sizes, right? So here, in particular, A is the area of cross section of the body. So keep in mind, A is the area of cross section of the body. Okay, right? See, what are the units of stress? SI unit is Newton per meter square. SI unit is Newton per meter square, and CGS unit is dynes per centimeter, right? So CGS unit I didn't write there, but if you know the SI unit, you can converts, so you can easily convert into CGS, right? So anyhow, the SI unit of stress is Newton per meter square or Pascal. Actually, Pascal is the name of the scientist. So to honor the scientist hard work, right, which helps for us for our human life, so we are using his name as a unit, that is what Pascal. So Newton per meter square or Pascal. And you can also remember 1 Pascal is equal to 1 Newton per meter square. Next, dimensional formula. Dimensional formula, right? Okay. See, you know how to write the dimensional formula. In the first chapter, measurement, units and measurement, there I explained you how to write the dimensional formula. So to write the dimensional formula for one particular physical quantity, first you have to know the formula, right? So the formula is clear, that is force by area. Force dimensional formula, mL t to the power of minus 2. I mean m power 1, L power 1, t power minus 2. See, in the denominator area, that is what L square, right? When L square go to the numerator, then it is L power minus 2. Already L power 1 is there. So due to these mathematical operations, I mean, that is what powers and base, by equating base and powers, right? So that we are getting dimensional formula for stress as m power 1, L power minus 1, T power minus 2. T power minus 2. Okay, right. Next, see here. There are 3 ways in which a solid may changes its dimensions when an external force acting on it. Am I right or not? There are 3 ways, right? There are 3 ways in which a solid may change its dimensions when an external force acts on it. Okay? Suppose, for example, if you take a cylinder, this is what cylinder, right? For example, if you take a cylinder, this is what cylinder, you please observe, this is the length of the cylinder. Okay, it is the extended position, that will be different. I will explain you later. So this is what cylinder. Both are same. Here just the length is going to increase. It is before increasing the length or actual position. Okay, right. See, in case of cylinder, here the cylinder is stretched by 2 equal forces applied normal to its cross-sectional area. This is the cross-sectional area. This is the cross-sectional area. So by applying normal to the cross-sectional area, we are increasing the length of the cylinder. So the cylinder will become stretched position, right? So the cylinder is going to stretched by 2 equal and opposite forces normal to its cross-sectional area, right? In this example, in this situation, you can say that that is the restoring force per unit area in this case is called as tensile stress. The force is applied normal to its cross-sectional area. The restoring force per unit area is called as tensile stress, right? Okay. You just imagine, there is no picture, but we have to imagine. Even though you can compress the cylinder, if you compress that, then it will be called as compressive stress. Situation is same, but in one case the length of the cylinder is going to increase, in another case it is going to decrease. But anyhow, the length is going to change. That is what, because of applying some external force, that is called as deforming force, right? Suppose if the cylinder is going to compress, if the cylinder is compressed means, then it is compressive stress. It is compressive stress. Okay, right. So the tensile or compressive stress can also be termed as longitudinal stress. Longitudinal stress. So longitudinal means, you just keep in mind regarding the length, right? So by combining this tensile and compressive stress, you can also call it as longitudinal stress. Okay. In both the cases, whether it is tensile stress or compressive stress, in both the cases there is a change in length. There is a change in length. Okay. So when there is a change in length, the change in length delta L to the original length L of the body is known as longitudinal strain. So it is what? Change in length. It is what? Original length. So if you subtract L plus delta, if you subtract L from L plus delta L, then you will get it as delta L. So longitudinal strain is equal to change in length by original length. Change in length by original length. Okay. That is what? Delta L by L. Okay. Suppose if you take another body, suppose if you take another body, then what about that particular situation? See here, this is what. So another body with different shape, a body with different shape. So when compared to this, this size is going to increase, right? That is what. And the position where you are going to apply force also will be different, right? So here you are going to apply the force, and that is what, here also you are going to apply the force. So in this case you applied the force here and here, otherwise compressive means in this opposite direction. But here you are going to apply the force tangentially. You are applying the force tangentially, okay, right. So in this case, you just observe these two pictures. When I am explaining, you just see the two pictures. If two equal and opposite deforming forces are applied parallel to the cross-sectional area of the cylinder, here perpendicular to the area of cross-section, here parallel to the area of cross-section, then what will happen? There is a relative displacement between the opposite faces of the cylinder. These two are the opposite faces. It is the relative displacement. Okay, the restoring force per unit area developed due to the applied tangential force is known as tangential or shearing stress. Tangential or shearing stress. So the restoring force per unit area developed due to the applied tangential force is known as tangential or shearing stress. See here, that is what, right. Here itself, what is shearing strain? See, because of, as a result of tangential force which applied here and here, there is a relative displacement delta x. There is a relative displacement delta x between opposite faces of the cylinder as shown in the figure, right. This is the figure now. The strain so produced is known as shearing strain. Shearing strain. And what is the formula and how can we define? So the shearing strain can be defined as the ratio of relative displacement of the faces delta x to the length of the cylinder L. To the length of the cylinder L. That only I am writing here. See, shearing strain is equal to delta x by L, that is equal to tan theta. Theta is the angular displacement. And you know the formula for tan theta, that is what? Here, opposite side by adjacent side, no? So the formula for tan theta is opposite side by adjacent side. Sin theta is equal to opposite side by hypotenuse. Cos theta is equal to adjacent side by hypotenuse. Tan theta is equal to opposite side by adjacent side. Okay. So that also we are using here. So shearing strain delta x by L is equal to tan theta. Okay. If theta is small, you can take approximately tan theta is identically equal to theta. Then there itself you can say delta x by L is equal to theta also in case of shearing strain, right. Now we are going to take another object, that is what literally spherical shape, right. Spherical shape, just now I told you. So objects or bodies are available in different shapes now, in different shapes. That's why now we are going to take another body, that is what in spherical shape. See here, you can see on the board. In case of spherical shaped body, if I am going to apply a little force, what happens to that, and what type of stress and what type of strain? See, it is what actually hydraulic stress. It is hydraulic stress. Okay, right. Here in case of this picture, it is before going to apply these forces, it is a solid sphere. It is a solid sphere. Because of this pressure, pressure means force per unit area. Okay. So because of these forces and because of this pressure, compressed uniformly on all sides. No. So because of the force applied by the fluid acts in perpendicular direction at each point of the surface, and the body is said to be under hydraulic compression. Hydraulic compression. This leads to decrease its volume. This leads to decrease in its volume without any change its geometrical shape. Without any change its geometrical shape, right. So we can say that the body develops internal restoring forces that are equal and opposite to the forces applied by the fluid. Applied by the fluid. Okay, I will repeat once again. See, when you are going to apply some external force on a solid sphere, the body develops internal restoring forces that are equal and opposite to the forces applied by the fluid. Applied by the fluid. Okay, right. Now, the internal restoring forces per unit area. The internal restoring forces per unit area is known as hydraulic stress. Is known as hydraulic stress. So I have written here, you can observe. The internal restoring force per unit area is known as hydraulic stress, and in magnitude which is equal to the hydraulic pressure, So hydraulic pressure means what? Applied force per unit area, which is called as hydraulic pressure. Okay. Now, the strain produced by the hydraulic pressure is called volume strain. And is defined as the ratio of change in volume to the original volume. See, mathematically you can write volume strain is equal delta V by V. The strain produced by a hydraulic pressure is called volume strain. Okay, right. So till now in 9.3 we discussed 3 different types of stress and 3 different types of strain. So one is longitudinal stress and there itself longitudinal strain. Second one is shearing stress, shearing strain. Third one is hydraulic stress, that is what volume strain. Okay. So you can also call it as like hydraulic stress and then volume strain, otherwise volume stress and volume strain also sometimes. Okay, right. Next continuation to this 9.4 Hooke's law. So I already discussed to you about Hooke's law in our previous class, but here once again they have given mathematically and clearly. You please try to observe. For small deformations, see why he mentioned for small deformations. Suppose if the deformation is large, body will get permanent deformation. So when a body will get permanent deformation, it will become like plasticity. It is a plastic material. So there we can't talk about elasticity, right? So for every body, right, even though it is elastic material, there is a limit for its elastic behavior or elastic property, right? So within the elastic limit, you can say that within the elastic limit. Otherwise you can also say for small deformations, stress is directly proportional to strain. So when you are going to remove the proportional symbol, so obviously some constant will come now. So stress is equal to K into strain. K is the proportionality constant and is known as modulus of elasticity. Right? So K is the proportionality constant and is known as modulus of elasticity. Right? So in our upcoming classes we will discuss about what is modulus of elasticity and what are the types of modulus of elasticity, okay, etc. But till that you just remember here K is called as a modulus of elasticity. Okay. Hooke's law is an empirical law and is found to be valid for most of the materials. However, there are some materials which do not exhibit this linear relationship. That is what stress is directly proportional to strain. Okay, right. So in this class we discussed about stress and strain and Hooke's law. So in case of stress and strain, we discussed what is a restoring force, and in case of different shapes of a body, right, in case of cylinder and in case of next, that is what with the larger area of cross section, and in case of solid sphere. So we discussed what is longitudinal stress and what is longitudinal strain, and after that what is a tangential stress or shearing stress and shearing strain. Then we came to discuss what is hydraulic stress and what is volume strain. So after that we continued with 9.4, that is Hooke's law. Okay. So in our next class we will continue with the stress strain curve, that is 9.5 stress strain curve. Thank you.